Math is a wonderful thing. Math is a really cool thing.
Hi, my name is Crystal Flores.
I'm Doris Solis. I'm Jennifer Castillo.
I'm Ernesto Homer.
And we're Group 5.
Hi, my name is Doris Solis. I'm in group number 5. And I got question number 2 for analyzing data. Now, in the question, it asks the average life expectancy in the United States, which is L, has been rising steadily over the past few decades as shown in the table below. Let T be the number of years since 1920. So T equals the number of years since 1920 and L equals life expectancy in the US. So in letter A, it said to create a scatter plot of the data using software. So first of all, I had to make a table. I put the year and then the life expectancy. And then from 1920, it would be 0, 10, 20 years, 30 years, 40, 50, 60, 70, right? So now I said to create a scatter plot, I used Excel and I just input the number of years. In here, I put 0 through 70 and the life expectancy. And I just simply put graph to a scatter plot and it gave me this graph. Now for letter B, it said to compute the linear correlation coefficient using software, so interpret R. So I use the software, same thing, I just put correlation and I put in the points, the data points, which were 0 through 70 and the life expectancy. And it gave me R, which is my linear correlation, it equals to 0.9947. Now for letter C, it said to find the equation of regression line for LT. And with the regression line, the formula, it's y equals ax plus b. It would be y equals 2.874x plus 57.692, which is your y hat, because it's your predictor, right? So letter D, it now asks me to estimate the average life expectancy in the US in the years 1952 and 1960. So using the linear regression, not exactly this, because we're using our predictors. It's the best predictor of life expectancy. So all we did was from 1920 to 1952 is 32 years. So that's what we plugged in for X. And then for 40 years, we put 40. And it equaled to 149.66. And from 40 years, it equaled, their life expectancy was 172.65. All I did was add them up and divide it by 2 because it asked for the average of these 2 years. And the life expectancy for those 2 years, the average would be 161.2 years. So now for letter E, it said to compute the sum of squared residuals for the model. I want to get the residual squared. So from the residual squared, we pretty much squared all these numbers, and which gave us these answers. Now the question asked to compute the sum of squared residuals for the model. Pretty much it's the sum of the squared residuals. You just add all these numbers up, and what I got was 93,673.6361. F asked if we found a different linear model to predict our data and found its sum of squared residuals, would it be larger or smaller than the sum of squared residuals, and why? So again, the linear model, our regression line, it's pretty much a straight line that describes how a response variable y changes as an explanatory variable x changes. So the model is used to predict the value of y for a given x. So no line will pass through all data points unless the relation is perfect. So if we had a different model, linear model to predict our data and found its sum of squared residuals, it would be larger.
I'm Ernesto, and I'm in group 5, and I'm going to be going over binomial random variables. So our problem is 2 fair dice are rolled 19 times. Suppose we want to know how often we will get 7s. So I've already created a chart here to indicate how many times out of 36 possible chances that we will get 7s, and total is going to be 6 out of 36 times, and we'll reduce that down to a 1/6 chance of getting a 7. So for problem A, create a probability histogram for the binomial variable x equals the number of 7s in 19 rolls. Now, to calculate that, we're going to use the binomial PDF that you would normally find on a TI-84 calculator. So let's just go ahead and list our variables real quick. We have n is the number of times we're rolling the dice, so it's 19. The probability that we'll actually hit the number, which we've already said is going to be 1/6, and we're looking for the probability of x equals 7. So this is why we're using binomial PDF, because x is equal to 7. And this is the answer we're going to get with 19, 1/6, and 7. Moving on to problem B, find the standard deviation of x. To calculate the standard deviation, we're going to use the number times the probability, and then we're going to subtract 1 minus the probability itself. And when we enter those numbers, we're going to get 1.624. To find the expected number of 7s that will be rolled, we're going to use the expected value equation, which is the expected value of x equals number times probability. So it's going to be 19 times 1/6 gives us 3.167. And lastly, what is the probability that 7 occurs at least 8 times? So if you recall earlier, I said that in the event that it's equal to a number, we're using binomial PDF. We're actually going to use CDF now, since we're looking for how many times 7 occurs at least in 8 rolls. So x is going to be greater than or equal to 8, and so we're going to calculate this instead of 1 minus the probability of x is less than or equal to 7. And we're going to plug that in the calculator, and that gives us 0.0079.
My name is Crystal Flores. I'm in group 5. I'm going to be explaining problem 1 of probability. Okay, so in a survey of 210 people, the following data were obtained relating gender to color blindness, and that's going to be right here for you guys. And then a person is randomly selected. What is the probability that the person is A, male? So for this one, you have to find out how many in total of male we have, which is 125 right here, out of the total of all the people that they had in the survey, which is 210, to find the probability. And right here is your answer for that. The next one, B, is going to be colorblind out of the total. So the total of colorblind is right here, 136. Out of the total of people is 210. And then this is your answer for that. C, we have male and colorblind. So we have to look at the male and colorblind to see what that number is, which was 79 out of the total 210, and it gives us this answer. For D, male, given the person is colorblind, we have to, it's not going to be the total, it's just going to be given that the person is already colorblind, so our total is going to change from 210 to 136, because there's only 136 people that are colorblind. So for the bottom, our total is going to be 136, and male, given that they're colorblind, would be 79. So this is our equation, and this is our answer. For E, we have colorblind given that the person is male. So now our total is going to change again because it's given that the person is male. And total for male is 125. And then male and colorblind is going to be 79. And this is our answer for that. For F, we have, are the events male and colorblind independent, and why? To figure that out, we have this equation right here. If the probability of male and colorblind is equal to the probability of male times the probability of colorblind. If they equal, then it should be independent. If they don't equal, then it's not independent. And here we wrote down the equation for you, and the answers, since they did not equal, they're not independent. And the same goes for here. Are the events female and colorblind independent, and why? So here's the equation again, and here we wrote it down for you with the variables, and they weren't equal again, so they are not independent.
Hello, my name is Jennifer Castillo. I'm in group 5. I am going to be doing problem number 2 from the probability section. It is 2 fair dice are tossed, and the up face on each die is recorded. Find the probability of observing each of the following events. So to solve these problems, we create a chart to show die number 1 and die number 2. So 1 through 6 for each side of the die. For the first part A, it's a 2 does not appear on either die. So I had already worked it out. What I did is I completely crossed out the 2's, which is on die number 1, 2, and die number 2. So they're entirely out. So I check marked for each time that a 2 doesn't appear. So it's 1 and a 1, check. 3 and a 1, check, because obviously a 2 doesn't appear. So I checked out through the whole table and I got 25. So you're gonna do 25 out of 36 because that is the total amount of sides that we get for these computations, and the probability is 0.69. I did round off because it's too long of a number and it's easier to round. Now part B is the sum of the numbers is even. So I worked this out also. 1 plus 1 is 2, 2 plus 1 is 3, and so on and so forth. So they want the sum of the numbers is even. So I'm gonna count the even ones. So I'm gonna go ahead. For me, I'm a very visual learner, so I like to circle them in another color so I can make sure I have it accurately. So I'm just gonna circle all my even numbers that I got. So 10, 8, 6, 6, 8, 10, 12, 10, and 8, which got me 18 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and I am missing one. That is why it's good to have them circled right here. 18, there you go. So I'm going to do 18 out of 36, which equals 0.5. Now part C, it wants me to find the probability that the product of the number is odd. So product is multiplication, so 1 times 1 is 1, and so forth. You compute it out. So it has to be odd, so we have 1, 2, 3, and none of these are odd. And we'll go on to the next one. 1, 2, 3, 4, 5, 6, all even, 7, 8, 9, and so then it would be a total of 9, again out of 36, which will equal to 0.25.
Wait, I'm gonna have to like turn like